Okay, now calculus gets really fun. We're going to get into basic differentiation rules. Now, just don't bring anything to class and throw it at me after I show you these, because you're going to be a little annoyed that we use that definition of a limit so extensively. Let's look at a constant. The derivative of a constant is 0. Now think about what that means. All that means is the slope of a constant function is 0. Now, if you want to go back to the definition, the limit, let's go back to the original definition of a function. Say the limit as x goes to some constant c of f of x minus f of c divided by x minus c. Let's say our function, instead of calling it c, let's call it f is just equal to k. All right, then this becomes the limit as x approaches c of k minus k divided by x minus c, which is 0. All right, turn off the video and work a few of these. Now, k is just a constant and e is 2.71. Again, just a constant. Turn the video back on when you're ready to proceed. Now let's look at the power rule. If n is a rational number, then the function f of x is equal to x to the n is differentiable, and d dx of x to the n is equal to n times x to the n minus 1. All right, let's do this. Let's look at, let's see, d dx of x to the n is the limit. Let's use the delta x formula now. Delta x goes to 0 of x plus delta x to the n minus x to the n divided by delta x. Now, if we expand this, we get a mess. I know that, but that's okay. It becomes x to the n plus n x to the n minus 1 times delta x plus n minus 1 divided by 2 times x to the n minus 2. Now, delta x is squared plus, and we could continue, plus x to the n, so that's the expansion of this first term, minus x to the n, all divided by delta x. All right, now let's look at what happens. Change colors here. This x to the n goes away. And now what I'm going to do is I'm going to factor a single delta x out of every term. All right. You know, this should be delta x to the n. Y'all really have to, keep me on my toes because I drop things all the time. All right, so let's look at this. This is the limit as delta x goes to 0. And I'm going to factor the delta x, okay, divided by delta x here. All right, when I pull delta x out here, I get n x to the n minus 1 plus n minus 1 over 2. And I'm going to have x to the n minus 2 times delta x plus, now every term from here on out is going to have a delta x in it. And this is going to be delta x to the n minus 1. So when we divide out the delta x's here, we wind up with the limit as delta x goes to 0, I'm making mistakes everywhere, of n x to the n minus 1 plus n minus 1 over 2 x to the n minus 2 delta x plus dot 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 plus delta x to the n minus 1. And of course, all these terms go to 0. So as delta x goes to 0, those terms go to 0, so we're left with n x to the n minus 1. Now it turns out we can expand this to non-integer terms, but we'll do that later. All right, turn off the video and see if you can do these problems. Now the constant multiple rule is pretty straightforward. If f is differentiable and c is a real number, then fc is differentiable, and the derivative of c times f of x is just c times f prime of x. Now, I'm not going to go through this. It's a very straightforward proof using the definition. Quite clearly, if you have a c in every term, it's just going to get factored out. So, tell you what, let me do one of these for you. What if we do f of x is, oh, give me a good function, x cubed, all right, and c is 4. Then f prime at x, using the power rule from before, is 3x squared. So c f of x is 4x cubed. So the derivative with respect to x of c f of x is just c times f prime. So it's going to be 4 times the derivative of f prime of x, which is 3x squared. So this is 12x squared. Now, your turn. Turn off the video. Do those. Don't let that negative sign bother you at all. Now, the sum and difference rules are, again, really straightforward. The derivative of a sum is equal to the sum of the derivatives. The derivative of a difference is the difference of derivatives. So suppose I have f of x is x and g of x is x squared. Then f prime at x is 1x to the 1 minus 1. So this is basically x to the 0, which is just 1. And g prime of x is 2x to the 2 minus 1, or just 2x. You'll get to where you can do these in your head. And I apologize if I jump ahead and just sort of skip. So f plus g, the derivative, and you see I'm going to put this little prime on the outside. That's a shorthand. Just saying I want to take the derivative of f plus g prime is f prime plus g prime. So if I were to take f plus g, this is x plus x squared. The derivative with respect to x of f plus g is just the derivative with respect to x of f plus the derivative with respect to x of g. Now I've already done them up here. So this is 1 plus 2x. Basic principle, whenever you have a polynomial, if I take the derivative with respect to x of f of x, that's going to be the derivative with respect to x of x cubed. Now I'm going to go on and pull out this, let's do plus, d dx of minus 5x squared. I could have pulled out the negative sign, plus d dx of 4x plus d dx of 2. We'll do these one at a time. The derivative with respect to x of x cubed is, bring it down, 3x to the 2 minus 1, and I'm going to show you these in painful detail. And then this is minus 5 times 2 times x to the 2 minus 1 plus 4 times x to the 1 minus 1. And of course, the derivative of constant is 0. So this is 3x squared minus 10x plus 4. Your turn. Stop the tape. Do these problems. It doesn't matter whether I use a y or f of x. Now, let's look at the derivative of sines and cosines. Just memorize these. I'll prove these in class for you. Basically, the derivative of sine is cosine, and the derivative of cosine is negative sine. It's really pretty. Oh, skip there. Sorry about that. It's really pretty straightforward. Actually, you know what? Why don't I go on and do sine for you? You have to use a trig identity, and I want you to go and see that. All right. So d dx of sine is the limit as delta x goes to 0 of sine x plus delta x minus sine x divided by delta x. Now, remember the sine A, sine B. We are going to expand this. Okay, sine of A plus B is sine A cos B plus cos A sine B. So this is sine of x cosine delta x plus cosine x sine delta x. And then, of course, we have the minus sine of x still here, divided by delta x. So let's look at the limit as delta x goes to 0. And what I'm going to do now is I'm going to factor a sine of x out of this term right here. So this is, actually I need sine of x. So I need to factor sine of x out of here. So it's going to be sine of x times cosine of delta x minus 1 plus cosine x sine of delta x all over delta x. Now I'm going to do a little bit more trig here. I'm going to take the limit as delta x goes to 0. And this is, I'm going to switch this around, make that 1 minus cosine x and take a negative there. I'm going to switch these over. So this is cosine x times sine delta x over delta x. And then it's going to be minus sine of x times 1 minus cosine delta x over delta x. Now I did this because I know that these are 1. So this becomes the limit as delta x goes to 0 of cosine of x minus, excuse me, that goes to actually 0, sine of x times 0. So that's 0. And as delta x goes to 0, this actually just becomes cosine x. Now, for these, very straightforward. F prime of x is going to be 3, derivative of sine is cosine. G prime of x is 5, derivative of cosine, it's minus 1 sine. So this is negative 5 sine of x. All right, your turn. Do these in your notebook. When you're done, turn off the tape. Have a good evening. Finish your homework.